So in this video, y'all, we're going to go over the Quiz 7 review. First problem says find the inverse of the following function. So if you recall, what we're going to do here is we're going to swap our x and y and solve for y, but we're also going to change it from a log to an exponent, okay? So our first step is, if you recall, sorry, this is y. So we're going to swap our x and y. So that's going to be x equals log. And remember, when there is no base, there's a base of 10. Y'all remember that? Okay? So now we're going to do 2y plus 1. Now we're going to change this from a log to an exponent. So we're going to take our base, 10, and we're going to take it to the x power, what's on the other side of the parentheses, or the equal sign, and then we're going to set that equal to 2y plus 1. Okay? So obviously we're going to have to subtract 1 from both sides. So that's going to give us 2y now is equal to 10 to the x power minus 1. And then we're going to divide both sides by 2. So y is going to be equal to 10 to the x power minus 1 divided by 2. This is our inverse function, okay? So our next one, once again, remember, this is y, so we're going to swap our x and y. So x is equal, again, to log base 3 of 8y. So this time we're literally going to go ahead and do the base 3 to the x power. That's going to be equal to 8y. Remember, our base is always our base, and whatever's on the other side of the equal sign, that's what we're going to take to the power, and then we're going to put the of statement next, okay, as the equal sign. All right, so now we're going to divide both sides by 8. So y here is going to be equal to 3 to the x power divided by 8. Okay? All right, this next one says find the inverse of the functions as well. So we're calling again, that's still our y. So now we're going to say x is equal to 2 to the y power plus 5. We got to get that base to the exponent of y alone. So we got to actually subtract 5 from both sides. So now we have x minus 5 is equal to 2 to the y power. Now we can put this in a logarithmic format, right? So our base is our base. So we've got log base 2 of what's on the other side of the parentheses, x minus 5, and that's going to be equal to our y. So that's our answer here. And the next one, again, same thing. So this is our y. So we're going to swap our x and y. So this is going to be x equals 4 to the y plus 7 minus 1. So we are going to have to, again, get rid of that negative 1 first. So we're going to add 1 to both sides. So this is going to be x plus 1 equals 4 to the y plus 7. So now we're going to take this and put it in a logarithmic format. So our log base 4 of what's on the other side of the equal sign, the x plus 1. And then we're going to take that's going to be y plus 7. So now what we need to do is obviously subtract that 7 from both sides. So this is going to be y is equal to log base 4 of x plus 1 minus 7. And that is our inverse function. So to find this next pair of inverses, we need to know that the inverse of ln is e. Okay, so the very first thing we're going to do, again, same thing we've been doing, is swap our x and y. So we're going to make this x, and that's going to be ln of y plus 4. Now recall that to get rid of an ln, we must do an e. So this is going to be e. So those, sorry, I don't know why that did that, but so over here, the ln and the e cancel each other out. So we are left with our e to the x is equal to y plus 4. So yes, we're going to subtract that 4 from both sides. So subtract 4 and subtract 4. So our y is going to be equal to e to the x minus 4. Our next one, we're calling again, this is our y, right? So we're going to swap x and y. So x equals e to the y minus 2 plus 6. So we are going to subtract that 6 from both sides. So this is going to be x minus 6 equals e to the y minus 2. Okay, so now we're going to use ln to cancel out the e. Okay, So we're going to put an ln next to here, and we're going to put an ln next to here, okay? So that's going to give us ln of x minus 6. Now these cancel each other out, and we're left with y minus 2. So we will add 2 to both sides. So our final answer is going to be ln of x minus 6 plus 2. That's what equals y. All right, on number 4 and 5, well, let's talk about 4. 4 has an ln and e right next to each other. So these guys actually just cancel each other out, so we get what's left, okay? Right here cancels each other out again. So obviously these are like terms. So that's going to be x plus 5x. That's 6x plus 6. The next one says solve, okay? So on this one, we're going to solve for x, okay? So what we're going to do is we're going to take an e to both of these, because that's how we're going to get rid of that ln. So we're going to do e to the 4th, which is going to give us a number when we do that in our calculator. These two cancel each other out, and that's x minus 3, right? So now we're going to, whatever we get for e to the 4th, we're going to add 3 to it, right? Because that's how we get rid of that 3 that's on the right. So e to the 4th was 54.598. So we're going to add 3 to that, and that's what is going to be equal to x. So we get 57.598. That's what x is equal to. All right, number 6 is an investment of $8,000 or $800 earns an annual interest rate of 5.8% if the interest is compounded continuously for 5 years. Find the amount. So our formula here is A is equal to compounded continuously is our key phrase here. So we know we're going to use the P times E to the rate times time, right? So our rate is this right here, and this is going to be 0.058 because we're going to move that decimal place 2 places to the left. This is going to be our T. That's going to be our P. So we're going to take our P, our 800, and we're going to multiply that times E to the what power? 0.058 times 5. And you can do all of this in your calculator, guys. It's going to give you your answer. So the amount is going to be equal to $1,069.14. Okay? So the next one says the city population, which was initially 25,700 people, has been dropping 4% a year. So remember, this can be our 0.04. Which exponential function represents the situation? Will the population drop below 1,900? Okay, so on this one, we are going to take our initial amount, and that's going to be our 25,700. We're going to multiply that times 1 minus, because it says initially in dropping, right? 0.04 to the t power, right? And isn't that going to be equal to 19,000, y'all? Well, let me go ahead and clear up that little equal sign there so y'all can see it better. Because that's what our ending amount is going to be, right? 19,000. So that's what our formula is going to be, okay? So now what do we need to do? So to find this, what we need to do is we're going to divide the 19,000 by the 25,700, okay? And then we're going to do what's in that parentheses. So that's going to be 0.96, right, to the t power. So we're, again, going to divide that 1,900 by the 25,700. That's going to give us 0.7. Oh, where'd my pen go? 0.7393, and that's equal to 0.96 t, or to the t power, sorry. Sorry about that, y'all. That's to the t power. Okay, so everybody listen. So now can't we change this into a log? We can. So this is going to be log base 0.96 of 0.7393, and that's going to be equal to t. Now, if you recall, we can use the change of base formula here now. So we can say the log of 0.7393 divided by the log of 0.96. That's what t is going to be equal to. So you go ahead and do that in your calculator, and it's going to give you the answer 25 point, what did I get? No, wait, take that back. It's 7.4 years. What am I doing? I'm going to the wrong problem. This is, yeah, so when I do that, it is, yeah, 7.4 years. So T is equal to 7.4 years, okay? So now we need to look for our formula, this up there. So I got the 1900 on the left, 2500, 1 minus there. Okay, so, and then it's 7.4 years, right? So our answer is B. Whoops. All right, the next one says, how long does it take for an investment of $5,000 to quadruple at an annual rate of 5.5, that's our R, compounded continuously? Okay, so this one we're going to say 4 times our initial amount equals our amount, and then we're going to do what? E to the 0.055 t power, right? Okay, do y'all remember this? So we can divide both sides by p here, right? And so we're just going to get 4. I'm going to move this over. So we get 4 equals e to the 0.055 t power, right? So how do we get rid of the e? You guys got it? Yeah, so we're going to take the ln of both sides, okay? So that gets rid of that. So now we got the ln of 4 is equal to 0.055 t, right? So we're going to find the ln of 4, and I got that it was 1.3863, and that's going to be equal to 0.055 t. So aren't we going to divide both sides by 0.055? Okay, so t is going to be equal to 25.21 years. And if you want to check that, then you could put that 25.21 back up in the previous formula, this one up here, and you can see, do you get $20,000? Because 4 times 5,000 is quadrupling it, right? Okay? All right, so number 9 says, which equation represents the inverse? So on this one, again, this is y, so we're going to say x equals 8 times the third root of y minus 5. My first step is going to be divided by 8. So that's going to be x over 8 is equal to, again, the cube root of y minus 5. So how do we get rid of a cube root? Yep, we cube it, right? So we're going to cube both sides. So now we have x over 8 cubed. Remember, this cancels this, equals y minus 5, and then we have to add 5 to both sides, right? So it's going to be x over 8 cubed plus 5. That's going to be equal to our y. So that's our inverse, okay? So which one of those looks like that? Yep, D, okay. So the next one says the cost in dollars of enlarging a photo is given by the function c is equal to 0.4 w cubed plus 2, where w is the width of the enlargement in inches. Which function represents the inverse of the given situation? What is the width of the enlargement that costs? Okay, so what we want to do is solve for w, right? So we're going to say c is equal to 0.4 w cubed plus 2. So our first step would be to subtract that 2, right? So that's what we're going to do. So we get c minus 2 is equal to 0.4 w cubed. So now don't we need to divide by that 0.4 on both sides? You're right. So now it goes away from there. So we got c minus 2 divided by 0.4 is equal to w cubed. Now how do we get rid of a cube? Yes, we take the cube root. So we're going to take the cube root of the w cubed and of the c minus 2. So this is going to be w is equal to the cube root of c minus 2 over 0.4, right? So which one of those looks like this? It looks like A and B look like what we have. So we can cross through these two because they're not going to be true. Now, let's go ahead and plug our value in. So we're going to do the cube root of 58.75 minus 2 divided by 0.4. Well, when I did that, I got that I'm looking for the cube root of 141.875. When I take the cube root of 141.875, I got that W was equal to 5.2 inches, okay? So that means this has got to be my answer right there. All right, so number 11 says a principal of $300 is deposited in an account that pays 6.5% interest, 6.5, compounded weekly, key phrase there. Okay, so this is our formula. A is equal to P, 1 plus, our rate of interest divided by our time, which is N, okay? And then we're going to do our N times our T, okay? So we're going to say our amount is going to be equal to our principal, 300, times 1 plus, remember this is our rate, and it's going to be 0.065 because we're going to move the decimal place 2 places to the left, divided by compounded weekly. There's 52 years, right, or 52 weeks in a year. So it's going to be 52, and then we're going to do the 52 times our time right here. That's our T. 6, okay? So when we do all this, and I remember, if your calculator won't do all this like it's written here, then what you need to do is do what's in the parentheses here first, then take it to that power up there, and then multiply by 300, okay? But when you do this, the answer I got was $442.99, okay? All right, so the next one says, which statement describes the graph of 2 times 0.075 to the x power minus 3. Select the 3 that apply, okay? So first, let's look at this and see if we can figure out what the domain is. So the domain looks to me like it's what? It goes from negative infinity to infinity, doesn't it? And isn't that all real numbers? So looks to me like A is true. Okay, let's talk about the range. So what about the range? So it's looking to me like we're going to, now this is a exponential, right? So we're going to have an asymptote down here. You guys see it? Let's see if I can draw it. See this asymptote down here, guys? So that's going to be what? Y equals -3, okay? So that means my range is going to be what? It's going to go from -3 up to infinity, isn't it? It is. So we would also say that y is greater than -3, right? So those are the two ways that we could write our domain and our range. So is the range all real numbers? Definitely not, right? Because it's -3 to infinity. Does it have a vertical asymptote? Nope, it has a horizontal asymptote, doesn't it? It is y is equal to -3, so that's also true. Then as x approaches infinity here, y'all, what is y approaching? Isn't it approaching -3? So that's definitely not true. And then as we head towards negative infinity here, where's the graph headed? Towards positive infinity. There's your third answer, okay? So now we're going to go to the next one. So which statement is false? This one says, okay. So the first thing I want to do is mark the starting point of this graph, which is 2, -1, and recognize that it's headed left and up, right? Okay. So let's talk about our domain. So our domain is from negative infinity to over here on the right to 2, right? And that means x is going to be less than or equal to 2. Our range is going to be from -1 up to infinity, isn't it? So that means y is going to be greater than or equal to our -1, right? So now let's talk about, so remember, interval of decrease, it is an interval of decrease because it's falling from left to right. And is that from negative infinity to 2? It is. So that is true. And it is decreasing. So then it says, as x approaches infinity over here, what is f of x approaching? What is our y value? Is it -1? It is. Okay, now as we head to the left, where's the graph headed? Isn't it headed up towards infinity? It is. Okay, then the domain is 2 to infinity. Well, no, we already know that's not true because we wrote from negative infinity to 2. So this is your false answer, okay? Then the next one, number 14, says which statement is true about f of x is equal to log base 2 of x minus 1. Okay, so this is going to have a vertical asymptote, isn't it, guys? So that's going to be at x equals 1. Let's talk about, so it says true. Okay, so it doesn't have a horizontal asymptote, so that's definitely not true. The interval of increase is from negative infinity to infinity. Okay, so let's just talk about our domain here. What is our domain? Okay, our domain is from what? That 1 on to infinity, isn't it? Okay, and so what's our range? Our range is going to be, look, we've going down and it's going up, isn't it? So that's going to be from negative infinity to infinity, right? So we're going to use those. So the interval of increase, is the graph increasing? It is, from left to right. That's true. And is it increasing, though, from negative infinity to infinity? No, because our domain right here is our interval. So that part right there is not true. So this one's not true. This one's not true. The vertical asymptote is x is equal to 1. It is. We already saw that, okay? And then as we approach negative infinity here, what is our f of x approaching? What is our y value approaching? That, wait a minute. Oh, so the problem here is not that it's negative infinity. It's that it should be approaching what? That 1, right, y'all? That should be as x approaches 1, because that's where our vertical asymptote is, okay? So that's why that one is not true, okay? So that's why the answer was C. All right, now let's go on to the last 3. So solve for R. So we're going to do D is equal to the 8th root of R over T plus 1. So I'm going to take both of these to the 8th power, aren't I? So that's going to cancel out those roots. So this is going to be D to the 8th is equal to R over T plus 1. So I'm going to subtract 1 from both sides. That's going to be D to the 8th minus 1 is equal to R over T. And how do I get rid of a T in the denominator? Don't I multiply both sides by T? I do indeed. So R is going to be equal to T times D to the 8th minus 1. That's our answer. So this last one, or number 16, sorry, says solve for x. Okay, so I'm going to rewrite the problem first. 5 times x plus 8 to the 1/3, that's equal to 10. So what would be my first step here? Divide both sides by 5, right? That's going to give me x plus 8 to the 1/3 power equals 2, right? Now, how do I get rid of a 1/3 power? Don't I multiply by its reciprocal, which is 3? I do. So this is going to take care of all that. That's going to give me x plus 8. 2 times 2 times 2 is 8. And then aren't we going to subtract 8 from both sides? Indeed. So that's going to be x is equal to 0. And if you put 0 in there, if you take 8 to the 1/3 power, that's 2, and 2 times 5 is 10. So that is the correct answer. Okay? So this one says also solve for x. So we're going to do 3. I'm going to rewrite the problem again. Plus 5x minus 15 equals x. So I'm going to subtract 3 from both sides. So that's going to give me 5x minus 15 equals x minus 3. Now I got to get rid of that square root, right? So I'm going to have to square both sides. And if you recall, if you don't remember how to do what's down there, then do the box method, okay? The x minus 3 squared, okay? So, but we're going to use this to cancel that. That gives us 5x minus 15. That's going to be x squared minus 6x plus 9. Then we're going to do what? Subtract the 5x from its like term, and we're going to add 15 to its like term. So that's going to give us 0 over here, and that's going to be x squared minus 11x plus 24. So then we're trying to figure out what are the factors of 24 that add up to be negative 11. So that's going to be 0 is equal to x minus 3 and x minus 8, right? So then we're going to set each of those equal to 0. So that's going to be x is equal to 3 and x is equal to 8. Am I done? No, I have to check both of these, right? So we're going to do 3 plus the square root of 5 times 3 minus 15. And we want to see, does that equal 3, right? So this is going to be 3 plus the square root of 15 minus 15, which is going to be 0, right, y'all? So that's going to be 3 plus the square root of 0. So obviously that's going to be 3 plus 0. And that's 3, right? So does 3 equal 3? It does. Okay, so that one checks out. So we know that 3 is going to be one of our answers. Let's check the other one. So now we're going to do, again, 3 plus the square root of 5 times 8 minus 15. Is that going to be equal to 8? Okay, so this is going to be 3 plus the square root of 40 minus 15. So that's going to be 3 plus the square root of 25. It's lagging again, y'all. Does that equal 8? Well, this is 3 plus 5, right? And 3 plus 5 is 8. So 8 equals 8. So, yep, checks out. Now, remember, you could have just started right here with these two, right? To see, because we can see that the answers are 3 and 8, right? So you could have just checked them to see if they work. But the answer was C. Whoops. C. Okay?